Electron-neutrino collisions play an important role in particle physics and nuclear physics research. Through these collisions, we can learn new information about the fundamental particles and forces of the universe. Electron-neutrino collision process. The electron-neutrino collision can be divided into the following major processes. 1. Acceleration. Electrons can be accelerated to high speeds through particle accelerators such as accelerators. 1. Neutrinos can also be accelerated through these accelerators. 2. Collision. When an electron and a neutrino collide, an electron-neutrino interaction can occur between the electron and the neutrino. 2. This interaction means that electrons and neutrinos can interact in a variety of ways or fragment. 3. Energy transfer. The energy released in the collision can be transferred to other particles or forms of energy. 3. This energy transfer plays an important role in high-energy physics and particle physics research. 4. Creation of new particles. Sometimes new particles can be created in the collision. 4. This can lead to the discovery of new particles in particle accelerator experiments. Research through electron-neutrino collisions. Through electron-neutrino collisions, we can obtain the following information. 1. Properties of neutrinos. Neutrinos have no electric charge, so they do not interact with electromagnetic force. 1. Therefore, to study the properties of neutrinos, we need to use the weak force and gravitational interaction. 1. Through electron-neutrino collisions, we can study the properties of neutrinos such as mass, spin, and oscillation state. 2. Origin and evolution of the universe. Neutrinos are thought to have existed since the very beginning of the universe. 2. Therefore, through electron-neutrino collisions, we can learn about the origin and evolution of the universe. 3. Properties of dark matter. Dark matter is thought to account for about 85% of the universe, but its properties are still largely unknown. 3. Through electron-neutrino collisions, we can study the properties of dark matter. Electron-neutrino collision experiments. Experiments to study electron-neutrino collisions are being conducted at the following locations. 1. CERN's CNGS experiment. CERN is the acronym for the European Organization for Nuclear Research, located on the border between Switzerland and France. 1. The CNGS experiment launches neutrinos from CERN's neutrino laboratory in the Greek Sea, 130 kilometers from Italy, and detects them in a laboratory in Florence, Italy. 2. Japan's T2K experiment. The T2K experiment launches neutrinos from the Tokai Research Institute of Accelerators, KEK, in Japan, and detects them in a laboratory in Kanagawa Prefecture, Japan. 3. The NOVA experiment in the United States. The NOVA experiment launches neutrinos from the Fermi National Accelerator Laboratory in Florida, USA, and detects them in a laboratory in North Carolina, USA. Electron-neutrino collisions play an important role in particle physics and nuclear physics research. Through these collisions, we can expect to learn new information about the fundamental particles and forces of the universe. Additional details. 1. The energy of the electron and neutrino in the collision can be varied to study different aspects of their interactions. 2. The collision can occur in a variety of ways, depending on the energy and angle of the particles. 3. The products of the collision can be detected using a variety of methods, including particle detectors and imaging techniques. Electron-neutrino collisions are a powerful tool for studying the fundamental particles and forces of the universe. Through these collisions, we can learn about the properties of neutrinos, the origin and evolution of the universe, and the nature of dark matter.